All right, long answer number 2. You got to work on this one solo. Let's see what you did. The limiting resource in most aquatic ecosystems is phosphorus. Explain what a limiting resource is and how phosphorus pollution may lead to a dead zone. Okay, so I give you this little, hint here, right? That it's mostly phosphorus, but this isn't actually asking you anything about the question, right? It's just a useful piece of information for you. The real meat of what I want you to do here is this explain part. Explain what a limiting resource is, right? And how phosphorus pollution may lead to a dead zone. A lot of times, right, we saw resource referred to as nutrients, right, in aquatic ecosystems. So I'm going to go ahead and sub that in because they're about the same, right? And I'm going to highlight some keywords here that are going to be important in this question if I'm going to answer it fully, right? I'm going to need to talk about limiting nutrients, right? Some sort of phosphorus pollution, right? Maybe how phosphorus gets in waterways, and what is a dead zone? I'm definitely going to have to define that, right, if I'm going to answer this fully. So let's go ahead. I got some buzzwords that might be good. Things that come to mind here in terms of pollution, right? Watershed might be something that I want to throw out there. NPKs, right? Those are the other nutrients besides phosphorus that are important to aquatic ecosystems. Dissolved oxygen, going to be really important in the formation of a dead zone. Eutrophication, maybe. Kind of a stretch, but we can maybe connect that, right? So if you know something about eutrophication and you can talk about it and it's related to the question, go ahead. So those are some sciencey words that we might need to throw in there. So this first part of the question, explain what a limiting nutrient is, and, right, we're just gonna, let's stop here, right? Let's answer this first part here first, and then we'll move on to and how, right? So for the first part here, explain what a limiting nutrient is, right? So a limiting nutrient, right, is the nutrient that limits the amount of growth or success that organisms have in an ecosystem, right? That's hard to say, right? It's hard to explain what a limiting nutrient is. So in this case, I might take advantage of analogy. I might draw an analogy. Right? For limiting nutrients in particular, we talked about PB&J sandwiches, right? That the limiting nutrient is like the bread for the peanut butter and jelly sandwich, right? Even if you have a full jar of peanut butter, of PB and jelly, if you only have 2 pieces of bread, you can only make 1 sandwich. Right? In aquatic ecosystems, phosphorus, right, is the bread. So it limits the amount of growth and productivity that an ecosystem can have. There's usually plenty of nitrogen, plenty of potassium around, but it's that phosphorus that they're missing, right? So that's a good way if you're struggling to explain, in sciencey big terms what, a concept is, draw an analogy, right? Well, it's kind of like this, right? That's a very useful tool. So we've explained, sort of what a limiting nutrient is. You might want to beef this up a little bit and relate it to aquatic ecosystems, but definitely drawing an analogy can be useful here. Part 2, right? How does phosphorus pollution lead to a dead zone? So I'm going to need to define a dead zone. Right, it's an overgrowth of plant life and algae causes decreased dissolved oxygen levels because when the plants / algae die, right, even though these plants and algae are producing a lot of dissolved oxygen during the day, they sink to the bottom, and decomposers take up a lot of oxygen, breaking them down. Maybe, if you're a person who likes diagrams, maybe you draw a, diagram of dissolved oxygen levels. A graph or something. Definitely could be useful here, right? And you need to say, right, the overgrowth of algae, right, or sometimes called an algae bloom, is caused by an increase in nutrients. Right? When I say increase in nutrients, right, that should ring a bell, right? Phosphorus is a nutrient that's going into that waterway, and it's the limiting nutrient, right? So when you introduce excess phosphorus to a waterway, it's like giving the algae more bread, right? To go back to our analogy, right? The algae had a whole jar of peanut butter, a whole jar of jelly, and 2 slices of bread, and then all of a sudden we give it lots of bread, it's going to go crazy, right, and take over the ecosystem. So the final thing that you'd probably have to consider here is, what are sources of phosphorus pollution, right? Couple ways that phosphorus, and this requires that you have some knowledge of the phosphorus cycle, right? I know that those matter cycles were challenging for people, so you may need to spend some time with them, right, to look at the fluxes and things like that. Some main sources of phosphorus pollution are fertilizer, right? Phosphorus rock is mined and ground up into fertilizer and put on lawns. So if it runs off into a waterway, that's where the watershed comes in here, right? You could talk a little bit about that. It's going to increase plant growth. Another source of phosphorus pollution is soaps and detergents, right? You might have phosphate-free shampoo, right? That's because of phosphorus pollution, because your shampoo goes down your drain and then it goes to away. Where is away? It is in the watershed, right? So then it's ultimately going to flow back somewhere. And a third source of phosphorus pollution would be human or sometimes animal waste, right? So old septic systems, right, like the ones we saw around Squam, could produce some phosphorus pollution, right? So this phosphorus pollution from fertilizers, soaps, or human and animal waste could increase the algae, right, which when they die and sink to the bottom are going to suck up a bunch of oxygen, lowering the dissolved oxygen levels, right? You should definitely talk a little bit about, lower dissolved oxygen, possibly to the point where fish and other aquatic life suffocate. And if you wanted to take it the extra mile, right, you could talk about an example of a dead zone, right? Remember the Gulf of Mexico often has a dead zone, right in the handle of Florida and right where the Mississippi River comes out, right? Because it's dumping all that fertilizer from farmland into the Gulf, increasing the algae population and decreasing the dissolved oxygen, right? So if you touched on all these things, you'd have a killer long answer question.